Okay, so hello everyone, I'm Josselin and I'm part of the research and innovation team at ATEM, where we are trying to find and test new ways of improving video delivery. And today I'm going to talk about dynamic insertion, and more precisely, dynamic insertion in a low latency context. So let's get started. So the main goal of dynamic insertion is to provide to each viewer a personalized experience and give them ads that are more targeted to them than the more generic ads that could be included in the base live stream. The process of dynamic insertion can be done in several ways depending on the content. For example, for file content, such as VOD, we can insert the ad inside the video, and when the ad is finished, we can come back to, well, where we ended the actual live content, well, the actual VOD content, before we inserted the ad. However, for live, which is the focus of this presentation, this is not really possible. So for live content, what we want to do is replace part of the actual live stream in order to put our ad in there. So what we want to do is that basically we have this, a representation of a video with all those video segments there. And we want to indicate at the encoder level that we want an ad. Of course, we can't just do this like this, where we just put markers at random intervals. We also have some preparations to do at the encoder level. So at the encoder level, it has to adapt according to the ad marker it wants to insert. So in our case, this is KT35 markers, with the splice out indicating the beginning of an ad, and the splice in indicating the end of an ad. So the encoder has to adapt the segments it generates in order to introduce those ad markers inside the stream. So the segments that are just before the ad markers are shortened, such as an ad marker is always in between two separate segments, so that we can do this and replace everything in between the two ad markers with actual ad content. So then, when we are going to low latency, this is pretty much the same thing. However, there's a few differences. So this is the beginning of, let's say, the same stream as before, where we have our two segments, which includes several chunks that compose them, that the player will fetch one by one in order to be as close as possible to the edge of the stream. And basically, when we insert the ad marker that signals the beginning of an ad, that's the same thing as before. We have shortened segments and thus shortened chunks inside. After this, from the player side, what we want to have is the player requesting the first chunk of the ads we want to insert. And then it requests every chunk until the end of the first segment, and so on until the end of an ad. And at the end of an ad, of course, it goes back to the actual live stream. And the important point here is that the place where those two ad markers are the most crucial part of an insertion, as we do not want the video to have playback issue when switching from actual live content to ad content and from ad content to live content. So we have several problematics in our low latency DAI. The thing is, we do not want our ad insertion to induce any increase in latency. This is true for every kind of ad insertion, but this is even more true for, well, low latency ad insertion, of course. So what we want to do to prevent this is use something which is pretty fast, which modificates the actual manifest or playlists directly at the server side in order to give to the player something entirely transparent for it. Another things that we have to take into account when we want to dynamically insert ads in low latency settings, of course, is that we have to insert every ad segment and chunks basically the same way as the actual live content inserts its own ads and chunks. That means inserting every chunk at the same rate as the actual live content. And this is in order to prevent any playback issue that may occur, any buffering that may occur at the edge of the ad when inserting. And this is also in order to keep the player as close to the edge of the stream as possible. So to do this, we have to do some other preparations on the ad side with pre-generated ads, with various formats, with all their chunks already stored inside the server. And that's why I'm going to present you the low latency DAI architecture we made and used in order to achieve this. So this is a standard pipeline for live streaming, let's say, a very simplified one, of course. And we basically have the player here, which requests everything from the content, so the playlist and segments, to the edge cache, which will be useful later on, and the edge cache, which requests basically the same thing to the origin or packager. It goes, of course, with intermediary caches, usually, which are represented here with this dotted line. So when we want to do ad insertion and low latency ad insertion, we have to introduce some more components. So the two components that we are introducing are the ad server, which is there, which contains everything related to the ads we want to insert, the chunks, segments, and some modified playlists that I'll present to you later. And we have the what I call the DAI gateway there, which is the place where the ad insertion itself is done. So this DAI gateway there is preferably located very near geographically to the edge cache, so in the same cloud instance, for example, and communicates with both the origin and the ad server in order to get the playlist from the origin and insert the ads it gets from the ad server inside it. This is totally transparent for the player, as what the DAI gateway does is that it creates a new manifest with everything already inside of it, so the ads and everything, and it gets it back to the cache and then to the player. So there are a few things to take into account when we are doing this low latency ad insertion. The main thing, of course, is the protocol that is being used when we get the stream from the origin. So the main two ones that we've tested on were dash, multi-period dash, and HLS. And there are also other things to take into account that we can notice from the playlist we get from the origin, such as the bitrate resolution, things like this, in order to introduce some ads that are closer to the base stream as possible. And what we noticed was that when we are doing low latency ad insertion, HLS was somewhat stricter than Dash when it came to keeping the low latency while doing this ad insertion. So now we are going to zoom in a little on the components I introduced. So first we have the ad server here, once again. In this ad server, there's of course all the segments and chunks that compose the video ads in itself. But what I want you to take a look at more precisely is the ad playlist there. So this is a standard VOD playlist from the ad with various components here. The ones that are important for the dynamic ad insertion are basically only the init segments and the chunk segments, so the two in the middle. And the specific points that I want to talk about here is inside the chunk segments that we can see on this ad. So as you can see for this example of the first segments of the ad, every single chunk that composes this first segment and every single chunks of every possible segment of the ad are explicitly stated inside this playlist that was generated alongside all the chunks and segments we are using for the insertion. And this is so that we have minimal generation of parts and things to do when we are doing the actual ad insertion. Of course, a lot of the parts here may not be useful at all times. Usually we only keep the last 3 segments worth of chunks inside an HLS playlist that we explicitly put inside the live playlist. However, we can just cut out all the parts we don't need and we don't have basically anything to generate on the fly. So now that we have talked about the preparations done inside the ad server, let's talk about what's actually done in the DA gateway. So here on the left, you can see the original playlist that we get, the gateway gets from the origin. And there are several things to note. So first, there are the two tags that indicates the beginning, the queue out, and the end, the queue in of the ads inside the playlist that was inserted at encoder level and transmitted through the packager. And then when we want to insert the ad here, this is not really low latency ad insertion here since the ad is in the middle, of course, of a playlist, so we don't usually introduce the chunks there. But we just have to replace all the queue tags by discontinuity since they may be changes in profiles when we're inserting this ad. Of course, we want it to be as close as possible as well, but there may still be some changes. And after each discontinuity, we have to explicitly state the init segment of the following stream. So either the ad when we are introducing the ad, or the live init segment when we are going back to the live. And inside here, so the chunked segments from the ad that we have to insert, there's not a lot we have to do in this specific case. We add every single segment because the end of the beginning of the ad are inside the playlists. And the only things that we have to take into account is that we have to insert the correct date time tag. If we've done our work correctly in the preparation steps, we have something with segment size approximately the same as the live feed. So in this case, we just have to take those from the live feed directly, but we may make some corrections on them. And the only other things we have to indicate is for each segment the ad server base URL so that the players can know where to fetch the ad segments. So now let's talk about the more interesting use case, so the one where we are actually doing low latency ad insertion. And in there you can see, well, we've only had the beginning of an ad marker inside the origin playlist, and we do not yet have the end of an ad. So the ad is basically has to be inserted at the edge of the stream, and that's where we have to take into account all the chunks and try to do something for the playlist that is generated to be as close as possible in terms of length of the size of the window of the playlist, to be as close as possible to the origin playlist. So to do this, well, we have to see the time worth of segments and chunks that is actually in the live playlists and insert the segments and chunks of the ads that are correspond to exactly the same time when we do the insertion. If we do it this way, we do not have to generate the parts, as I said before, they were already in the playlists that we generated alongside the ads. The only things we have to generate, kind of, is the preload int tag, which is basically at the end of the playlist to signal which chunk is going to be next to be inserted inside the playlist. Since, well, the playlist of the ad is complete and has every segment and chunks in it, it's pretty easy to generate. So, of course, when we are doing ad insertion for one ad, we can do the exact same thing for 2 ads or even more ads. The only things we have to do is to keep a discontinuity tag somewhere, just in case there's a change in profiles in there. And the only chunks that we have to insert are the ones that are close to the edge of the stream. So basically, always on the last ad. So now that I've talked about the general dynamic ad insertion use case in low latency, I'll talk about 2 more topics that are closely related to it. So first, these are slates that we can use for ad completion because, as you may have noticed, for all of the examples I did previously, we had exact ad that was the exact amount of time for the expected ad time. This obviously may not always happen in real use cases. And what we want to do well, on our side to simply prevent this case is to have some things, some slates there, which can be, for example, filler content. So for example, blank screen for very small durations, or still logos or moving logos, anything that can cover a very short duration. And what we did there is that in the ad server, alongside with the ads, we also generated several slates that covers from duration from tens of milliseconds to 1 or 2 seconds approximately, so that no matter the expected time that we have to cover, we can basically fill up all the blanks that we need. So this is the simplest form of completing the ad when we are missing sometimes. And this is the one where we are using, but there are, of course, other means to do so. But I'd like to finish just by talking about one more important topic when doing dynamic ad insertion, which is the ad customization that we have to do, what we want to do when doing it. So in an ideal settings, what we would like to do would be to generate for each individual viewer a unique playlist. However, it may not be actually feasible because if we generate a unique playlist for each user, there will be a lot of traffic. We wouldn't be able to cache basically any playlists that are generated for efficiently at least. So in order to prevent that, we decided to use some ad pools, which are thematical ad pools. So basically, we have a set of tens of ad pools, for example, or hundreds, with different themes in each one. So basically, an ad pool for car advertisements, an ad pool for video game advertisements. And we want to, at the CDN level, so at the edge cache level, be able to pre-select an ad pool at this level already in order to be able to cache more effectively the playlists that are going to be generated by the DI gateway. So this preselection can be done with various parameters that are available at the edge cache level, such as the user agent, the location, or even more parameters that may be transmitted by the player, such as CMCD data or even more identifying data. And since each ad we have in our ad server is pre-generated with various profile and formats, so with different segment size, byte rate, resolution, and a lot of other parameters, those parameters are more on the technical side of the ad insertions, where we have to actually see what the origin playlist is in order to insert the one that are the closest to it. But on the thematical side, we only need the data that we could get at the CDN level. So the tests we made for our use case in order to test it were, of course, a little simpler than that. We had a few ad pools that were available, and we had a fairly straightforward conversion from CDN parameters and ad pool. But what it means is that basically what is inside this yellow box is the bottleneck of this whole architecture. As if we generate, for example, a single playlist for every single user, well, there will be a lot of requests made here and not a lot of caching done on the actual edge cache for the playlist at least. So what this achieves by preselecting the ad pool at the edge cache level is that we can influence the cache key here in order to cache more efficiently each ads that are generated for each ad pools, since we basically want only one singular playlist for a fixed moment t to be generated for a fixed ad pool. So in order to conclude here, well, I hope I've managed to explain how we've achieved this low latency ad insertion, which is pretty adaptable and does not need a lot more infrastructure or hardware than usual ad insertion. However, it may still need some more preparation, especially on the ad server side, in order to prepare all kinds of ad with various profiles, keeping all the chunks and fabricating the actual playlists that are going to be inserted. However, in the end, this is a solution that is pretty transparent for the player, and we still want to expand on it by doing tests with well, other things such as HS byte range, which we are planning to do pretty soon. So this is the end of my talk. Thank you for listening. And if you have any questions, please feel free to reach out. Thank you.